So um, I did miss the last two classes. We had recorded lectures, so from module two. And so what I did, I think originally the module two exam was going to be yesterday. I put it off a week so that I could actually at least make an appearance in person in class before the exam to see if there was anything um, that was up to question. Just a quick review. Like I was here for 2.1, where we did the SALT elements of strategic planning, which is where we talked about developing vision, mission, values, talked about what True North was, things that you are have a chance to put into use in the phase two of your project. Then in 2.2, we talked about lots of different approaches to doing competitive analysis. And from the project standpoint, wanted to use a few of those, but really use some of those to also gather information to complete your yellow card. How can you use that to articulate your benefit promise, your proof, do the raw math game? And then on strategy deployment, we went from identifying vision, mission, and values, the soft part, to how do we turn those into organizational goals? What are our key goal categories that we're going to measure success by at the strategic level? Whether it be calls, quality, delivery, people, whatever those metrics are. And those aren't really measurable, but they're kind of mini goal themes that will lead to deploying that down then to units, whether we deploy by value stream or deploy by department or business fundamental. I think in the lecture we talked about all of those. But say for each of the corporate strategic goals for each unit, what are your objectives to meet each goal? And what key results are we going to measure those objectives by to say we're successful or not? And then for each of the subunits below that, how do you develop your objectives and key results? Or in sometime, I think in the terminology I used, I broke it down to there are multiple tactics to meet each objective, and each tactic has a metric to it. And then there's multiple objectives to each goal. And we talked about how to deploy that down to hopefully create some level of alignment so that what I'm doing in my process meets some unit objective that was developed usually on an annual basis to meet some strategic goal that was developed as part of the strategic plan on a 3 to 5 year basis. And if I can do that, then I'm probably have deployed my plan very well and aligned. So that's what 2.3 was about. And then 2.4 was about, now that we've deployed the strategy, the plan, what are some things we need to understand in terms of executing the plan? And so I went through a case study, I think, of one value stream of a company that I worked on and how they developed the mission for that value stream, deployed it down, looked at how it's often very difficult to, and all this should be in the lecture, it's difficult to, if you've not done strategic planning in an organization, pick a pilot area to do that in and kind of walk through what that would look like in reality. And then how to have that system in place on a periodic basis at the process level to update how we're doing daily and weekly so that we can then report back up to the unit level or the operational level and ultimately back up to the strategic level. So we plan from the top down and we execute and report from the bottom up and do our plan, do check X. So that's what the last two sections that I wasn't here in person to talk about. So I wanted to give a little bit of time for those of you that are here, or if there were any questions before the exam next Wednesday, to see if there's anything left unturned on that. In other words, did that joker who taught this last year in the videos that I posted explain it well enough, or do I need to clean up his mess?
Was that is that analogous to what the guy and when they win, you win? He called it KTR cuts. Got the acronym, but
OKRs.
OKR, is that
Yeah.
analogous to that?
OKR stands for objectives and key results. So for each goal at the strategic level, then each department or however we deploy it will develop their objectives to meet each goal. And for every objective, there's a key result.
So it's kind of the same thing.
Yeah. What I covered, I integrated. I've been a part of strategic planning in a lot of different levels, from being an employee of a group that was part of a strategic plan to being a leader of a group who brought someone in to do a strategic plan for us, to leading strategic planning efforts for other companies. And so I pulled a lot of approaches that I like into kind of an approach, kind of a consolidated approach. And that's kind of what I presented in class. And so like it was pulling from a lot of different directions, just to kind of give you a broad survey of the different approaches. And so then to build off of that, tonight, what we'll start with is the last module in the semester, module 3.0 or module 3. So module 1, we spent 5 classes talking about how to learn to think strategically. And so we featured systems thinking. The 5th discipline was a lot of it. We talked about mental models and frameworks for competitiveness. And then we got into module 2, which was strategic planning. And we covered the strategic planning process. And then in module 3, we'll look at strategic leadership. So the last 4 class sessions. So we have 4 more class sessions, and then 2 sessions that will be the team presentations. So I think we have 8 or 9 teams going through. Sure. So it's kind of what what I hope the whole presentation is.
So like, I mean, I guess it sounds like it's open, right? So we could do a PowerPoint and show the Miro itself, or what do you?
So yeah, yes to either. So, and I can't remember, I guess project phase 2 is not due until next Sunday. Is it Sunday? I know a few teams turned it in early to get feedback, and I tried to give that. So I guess the phase 3 hasn't been made available. I don't know. Has the presentation assignment live and accessible? I don't
I
know.
don't think so.
But I can explain what I'll look for, and I'll do it more in the assignment. Hopefully I'll explain it more. But you'll have 10 minutes. Is it? I'll pick so much. I have no reason to be hiding it from you. You have 10 minutes, 5 minutes to pitch your idea. And what I want you to do, and this is why the yellow card is so important, is to be able to pitch in the same way. Here's our idea. Here's the name. Here's the news headline. The first, whatever. Here's the customers and the problem that it solves. Here's the benefit promise. Why should I believe you? Here's the proof. Here's the numbers. Here's some death threats and things that we still need to look at.
So basically, we're like the product champion.
Mm-hmm. And then the last 5 minutes, I want you to spend kind of just talking about what you did as a team. Not in excruciating detail, but just saying the first thing we did, we used these create tools, and this is what we thought about it. We used the 666 matrix, or we used this to create ideas. We created X number, and then this is how we cut it down to 5, and ultimately down to the 2 and the 1 that we just talked about. this is what we did for competitive analysis, and this is what we learned. And you'll have 5 minutes to articulate that. And then there'll be 5 minutes for questions. So what I will do is have, if I can, and I will, I just don't know who yet, recruit a panel. I like to have 3 people other than me that will then have questions, like you're trying to sell them, this is a good business idea, then they will ask questions. So think of, that's what you to prepare for. So it'll be kind of a fast-paced thing. So you can, however you feel that you can best represent what you did. And so you'll have 5 minutes to sell your idea and then another 5 to just reflect. Basically, that part's presenting to me. It's like, here's what we actually did. So you can present off the Miro board. There's some ways to do that makes it friendly to do. Or PowerPoint, however you feel, or commercial, puppet show,
Do like a Billy Mays style
or
commercial.
whatever you want.
And since
Puppet
our
show.
product is like, it's based on like hygiene, right? Can also just be like naked in the commercial.
Please don't.
Have to at least be pixelated.
Yeah, you have to blur it out.
Yeah.
Please don't.
Yeah. Probably not a great idea.
So a puppet show, right? That was the other one that you were talking about.
Yeah.
Well, it depends on who's naked.
Oh, I don't think they can depend. So that's kind of what to expect. I'll try to make that live and the presentation part.
It'll be 2 days of that because everybody can't fit in one day, basically.
And it would just be exhausting even if.
And that has to be in person, right?
So no, because some people don't live here.
Good.
So what we'll do, good question, is we'll all be on Zoom. That way we don't have some people live and some people on Zoom. That way we'll all be in one place on Zoom to do that.
And that'd be at a normal time.
It'll be normal class time. Just
What if your classmates have a job?
Hmm?
What if your classmates have a job? at that
then
time?
then they need to quit their jobs.
Sounds like what they tell me, yeah.
So is that the last 2 classes of the semester?
And what I'll do is I'll have y'all let me know, give me preferences on which day. Okay, should be available now. Just do this in no time. Also, March Madness brackets, fun for me. I've done one since I was probably 8 years old every single year, so I didn't want to break the streak, even though I've probably been able to follow it less this year than most. But I will say, if you did yours, and there's several people that are this, I have no idea who that is. Some of you submitted links, and if you submitted links to the actual assignment, I was able to give you credit. If I was able to decipher your name from some of these, I graded it and gave you credit. If it was this, I stopped trying to break the code. And as you can see, there's a few of those. Melanie, I didn't know this was yours. So if you did submit a bracket and you got a 0, send me who you are. Happy to update it. I hope you can understand. I just couldn't figure this out. So I would be remiss if I didn't at least offer that opportunity. So formal class sessions, and then 2 sessions of presentations, and then the final. And so the final will just be the module 3 exit exam, not a cumulative final. I don't think I've ever done a cumulative final in any class that I've taught. at the college level. I was inherently against them as a student and have not forgotten that all these years later. So that's what to expect going forward. So I want to kind of cover two things today as we start module 3, which is strategic leadership. I want to kind of spend probably the first 2/3 of class on managing the problem solving, because if we, the next level down, so we started with strategic planning, then based on strategic planning, deploy that down to the operational level, and then deploy that down to the process level. But then as we're executing our work at the process level, which is the daily and weekly things that we do, there's problem solving that keeps that going. And I just wanted to, I added this in, I think 2 years ago, and I've added some more to it because I used to cover it in another class that I don't teach anymore, but I still think it's important because it kind of closes the loop on everything from strategy all the way down to day-to-day process management. And so in the Getting the Right Things Done book, he talks about the plan, do, check, act cycle and problem solving. And so at the rapid level, the day-to-day level, plan, do, check, act can come into that mode. And so I think I know I mentioned in EM 660, but as my background was in lean and helping companies implement stuff on the shop floor, and then it grew into doing more strategic planning, and then it grew into we can improve processes and plan strategically, but if we don't have leaders at the process and we don't have leaders at the strategic level, then the execution of that's probably going to fall apart. And so the call for me when I was working on the research side and doing consulting was we need leadership training. And so my research center, the Center for Management and Economic Research here at UAH, several years ago, started to develop 5 leadership skills. And I'll touch on a little bit more at the end of the class, how they kind of tie in, but there were 2 of those 5 that dealt with managing the processes. There's day-to-day process management, and then there's problem solving, which is how to improve the process. So here's how we manage it, here's how we improve it. And then on the people side, it's the understanding of ourselves and our team members. And then there's the improvement and the development of ourselves and team members. And then where those 2 overlap, where blue and yellow make green, is the strategy deployment, which is how do we tie processes and people together to strategically run our organization. And so one of those, we're going to talk about this right side for the rest of the semester. We kind of talked about the strategy deployment in the last module, and we touched a little on 2.4 on daily process management. So the one piece that I did want to cover more is how to have the problem solving mindset. How do we develop that in our organization? So in other words, in Getting the Right Things Done, he kind of shows this. We have this plan, we go to execute, and things are not always, and by not always, never going to go according to the plan. And it's not that the things don't go according to the plan that ever causes the problem. It's the lack of a way to respond when they don't. And that's what problem solving is. So the inability to identify and properly problem solve is where execution falls through. And so there's levels of problems. There could be a bunch of day-to-day problems, but those are usually caused by some larger problem at the operational level that are usually caused by some bigger systemic problem, which is exactly what we see when we talked about systems thinking, right? Like we said, here's the tip of the iceberg, events, But those usually are caused by some patterns of behavior that are caused by some systemic structure. And if we can understand the bigger issues, we can get rid of more of these. And so, know how this doesn't get saved, right? But what is a problem? I use Taiichi Ohno, the pioneer of the Toyota production system, said, "No one has more trouble than a person who claims to have no trouble." Or no problems is the biggest problem. So if someone says there are no problems, they're lying. And how do we develop a mindset to where we embrace the problems as opposed to ignore or hide them? So a problem exists when there's a gap between what is and what must be. So any kind of gap. So there's potentially 4 types of problems. Types 1 and 2 are ones that are caused or reactive problems. And there's 2 ways to react to those. One is by troubleshooting, which means reacting when there is a problem by just patching up the symptom. And that usually is only effective to deal with temporary situations until you can get a permanent solution in place. A more effective way is a correction problem, which means we're trying to correct something from an underperforming situation back up to some defined standard. So there's a defined standard, the gap comes from underperforming, and we're trying to get that underperforming situation back up to correction. Or there's continuous improvement, which could mean we're performing at standard, but all of a sudden we need to get bigger, and the gap is from where we are to improving. And then there's open-ended, which are harder to quantify, and those are usually strategic situations. Identifying new products, new markets, innovation, things that y'all have been working on. So we've covered a lot in this. This is just reactive, and I don't want to encourage type 1. So we're going to focus on things we can develop for types 2 and 3. So some of y'all who had me as undergrads, you've seen some of this before and heard it from me. The number 1 trap is falling into this step 1 and then trying to identify, here we are, here's where we want to be, there's a gap, there's a problem, and try to skip the root cause analysis and go straight to some perceived solution. And when that happens, our problem solving efforts typically fail because we need to develop some sort of root cause bridge to help us get there. So what I try to tell my undergrads when I'm teaching more engineering type stuff, what I told companies when we were doing improvement events was I like to get rid of the word solution because that alludes to the fact that we fix something permanently and realize that what we're really trying to do is continuously improve with a countermeasure until the next improvement comes in. So developing the right mindset is important because if we just troubleshoot, a lot of times when we only fix symptoms, the problem keeps coming back. So I want y'all to take a little bit of time and read through some of these, with the black being here's the problem. And then the red being, does this fix the root cause? I identified a problem. These assembled parts won't align correctly. If my solution is using a hammer to make them fit, does that fix the root cause? Probably not. Having spent my time in dozens of manufacturing companies and done about 300 process improvement Kaizen efforts, anytime I saw anyone at a process using a hammer, I would stop and watch. Because very rarely have I seen that be the way things are supposed to be. And I knew it was a problem if somebody was using a hammer in a manufacturing process. Unless they're blacks, beating something on an angle. I'm like, I want to see what's wrong here. We had a batch of in-process work that had debris on it. And our solution is getting onto someone and writing them up. Does that fix the root cause of the debris? Or just treat a symptom? Developing a mindset to where we can properly identify root causes and avoid trying to react to treating symptoms is critical. Because I could say, so like I could have a symptom, right? Sick, have a fever, have chills. Those are symptoms, right? There are ways that I can treat that. Oh, I'll just wrap up in a blanket. The chills are gone. I'll take Tylenol. The fever goes away. And it will, right? For how long? A couple hours maybe, and it comes back because that's what treating symptoms does. But if I go to a proper medical professional or diagnose myself on WebMD, or if I go to a medical professional, a doctor, nurse practitioner, wherever, and they run tests, they ask me questions, they dig down and they find, oh, you have a sinus infection, Nick, it's spring. You always get those. That's what's causing the fever and the chills and all these symptoms. And they give me something to wipe out the root cause, all the symptoms go away. Permanent. Not just treating them temporarily. Same thing with problems. If we react to symptoms without understanding the root cause, very often we're not fixing the real problem and they just keep happening over and over. So developing a problem-solving mindset, and I pulled this from Getting the Right Things Done, talks about problem-solving in itself isn't a tool. It's changing your behavior to where you're thinking about getting to root causes, spending time in the plan phase of plan, do, check, act, and not just jumping to scientifically using the scientific method of problem solving. You said you don't have to have a science degree to be a good scientist and follow the scientific method of problem solving, plan, do, check, act, and learn to trust that. And that way we can go from reacting to treating a bunch of symptoms to saying, I want to understand the big problems that take care of a lot of the medium-sized problems that take care of a lot of the symptoms. And that's a little more strategic way of using my efforts. So in my career at different phases, there are different types of problem-solving methodologies that can be used depending on the types of problems that you have. But all of them follow the plan, do, check, act cycle. So we've talked about all semester innovation engineering, the strategic planning process. That's high level use of plan, do, check, act. At the mid level, there may be group type improvements. Like a weekly, monthly level, Kaizen events. I did a lot of those over my career. It would be a week. I would go and I'd work with 6 to 8 people. We would spend 3 to 5 days working on one focused problem. And then usually that would work in an area that would address a lot of smaller problems. In an even better world, when in alignment, there was some strategic plan and a value stream map that told us that we're working on the right problem here, dealing with these. And if we improve this problem, it's going to close the gap toward our strategy. Six Sigma and the DMAIC process, define, measure, analyze, improve, control, is another problem-solving methodology. In the software development world, and engineering world, agile project management has become a big thing, but they all follow very similar that to me, like they all follow the plan, do, check, act process, just under different terms. And then at the individual level, at the process level, there's practical problem solving routines, which is more individuals working with maybe a mentor to solve a smaller type. So they're all, there's not in my mind, I have tried to grow to be very robust in the types of problem solving methods that I've been exposed to, because while they may approach things in different ways, like a Kaizen event is quick and focused, 3 to 5 days, cross-functional team working in one area, they're dedicated for that short amount of time. That may be appropriate for some types of projects, but maybe not others. Six Sigma is usually not a dedicated team for an amount of time, but teams and individuals working on projects over a longer period of time. That may involve data collection and analysis, but that's not all they're working on. They have other responsibilities. And then agile project management, like I said, is another form of iterative incremental development efforts, stopping, addressing issues as they pop up in their sprints or whatever they are. And then sometimes smaller problems, practical problem solving, one-on-one approaches may be effective. So I'm not expecting you to become experts on all these different ones. What I'm trying to say is a problem-solving mindset is understanding that all of these follow the similar plan, do, check, act flow, just at different scales. But it's all about developing a problem-solving mindset. And part of that is one approach doesn't work for every type of problem. So, like I said, we talked about the ways to address open-ended problems all semester. The innovation engineering process, the strategic planning process. I try to discourage the troubleshooting approach, which is just jumping to do and skipping the plan phase of plan, do, check, act. So we'll focus on the right side for today. And so, like I said, there's two types of problems on the right side. A correction problem is having a desired situation, a standard that's established, but we're performing below that standard. That's a gap. And our problem-solving efforts in that case should be to correct the current underperforming situation back up to standard. But just like I said, we could also have a normal situation that's just fine, performing to standard, but we wish to improve. And that might be, we need to improve to continue to be competitive. What we're doing today is just fine, but we know if we keep performing at this level, we'll fall behind. That's what strategy is. That's also a gap, but it's not a correction gap from underperforming. It's raising our ability to perform at a high level. Either way, there's a current situation, a desired level of performance, there's a gap, and that's what problem solving is. So in general problem solving structure, and I'll kind of just go through each of these bullet points, but they follows the plan, do, check, act process. Regardless of the scale, it involves some sort of problem description, some ability to break down and analyze the problem and set some sort of target. And then based on the analysis of issues that we found, develop. Then we go and do. Then we check and see if we get better, and then adjust by reflecting on what we learned and either standardize the new process or return back to plan if we didn't improve and do it all. So one of the things I always try to emphasize is how to develop proper problem descriptions. So Those of you that are participating live in person or on Zoom, kind of read through these. We can talk about it. The first statement says there were a lot of people in line at the store. So in your opinion, how many are a lot of people? If I say a lot of people are in line, about how many people are in line for you to say it was a lot?
I think it's like 5.
5,
4, 6.
4 to 6. It's 5 plus or minus 1. To me, it's any. To me, it's like why I'm at the store, because I don't want to deal with the chance there might even be a line.
Self-checkout.
Yeah, right. Or there's not a line on my porch when Instacart just dropped it off. How about that? And so it's very subjective, right? The gym's too far away from the house. How far is that?
45 minutes.
45 minutes.
What's that in miles?
45. So always a 1-to-1. Unless you're in California, and it's like 10 miles, it's 2 hours. Some people may be 45 minutes. It'd be tough for me to drive 45 minutes. Mine may be 15. Mine's in my garage. If it wasn't there, I probably wouldn't get out and go in. So step 1 in problem description is we can't solve a problem that isn't properly quantified. We have to go from subjective, emotional thought to quantitative, objective thought. And once we can put in numbers, now that's a real problem that we can improve upon. But if we don't have a metric to improve upon, how do we know that we've actually problem solved? We can change things. How do we know we got better? So a proper problem description does not have junk words. And by junk words, I mean subjective things. So here's a bad problem statement. We have too many customer complaints. I don't know how too many are, how much that is. We need to pay more attention. I sure don't know how much more attention is. Do we go from 2 to 6 attention? I don't know how to measure that. And it happens a lot. Don't know what a lot is. Because it's subjective, right? It's a lot of junk words. But if we could reframe that exact same thing and say customer complaints have increased from 1% to 3% in 1 month. Okay, now I know exactly how much it's changed and in the time that's concrete. 3 reached the customer in June. Issues happen 6 to 8 times per shift. Now those are hard numbers, right? Good or bad, if I make a change, I can come back and compare metrics from those same categories and see if I got better or not. So a good problem statement is quantified. And if I haven't quantified it, it's kind of hard to say I've improved. I may feel better, but if I don't have the numbers, I don't know what I've improved upon. I don't know how the format got mixed up. Yes. So part of the problem solving process, it starts with being able to describe it. And description of the problem shouldn't include an allusion to a solution or a countermeasure. It shouldn't say the problem is not a lack of this. It's just alluding to what you want to do. It's just descriptively saying, here's the current situation and how it stacks up to what we designed. Then the next step is to understand why. And that's to drill down further. So our problem description may hint at a broad problem, but as we start finding out more information, following the problem solving process, we'll narrow that down to more specific reasons for each specific problem. So we usually start with a broad problem statement, then we use data visualization, to narrow it down. And then we go finally to a specific place for this specific problem that we can go and observe and develop countermeasures and be very methodical. And so I just wanted to show a few examples of different ways during the problem breakdown phase that you can visualize data to help with the problem solving process to get to root cause analysis. And now more than ever, there are ways to present data in a visual way, like there's whole fields in it that can help people understand data and problems. So I'm going to just cover a few basic ones. And there can be a lot of different types. Depending on what we're trying to understand, there's different types, ways we can visualize information. If I think the problem may exist due to some series of process steps or a flaw in the decision-making process, maybe a flow chart of some sort can help me understand how things are working. We looked at value stream mapping back in class 2.3 maybe, a little bit, or 2.4 or both. That's a form of a flow chart that shows here's the steps that go into making something from beginning to end. Or it could be a decision flow chart that leads to, based on the decision I make, here's the next step.
I'm gonna run over to grab
The flow chart is just a series of steps, whether it be making something or decision making. We've been in our department going through the process of trying to document a lot of processes that we have, including like how to process graduate students through. What does it look like from the time they apply to the time they're informed they're admitted, the time they do their program of study, to classes, to get them the heck out of here? What does that look like? And so lots of flow charting in understanding the steps, because trying to document the steps often shows you there's also flaws in the process. So if we think issues might be from a series of process steps, then the flow chart may be a way to help us visualize data. If it is due to the frequency of different potential causes of a problem, then some sort of check sheet could be beneficial. So it could be a simple tally sheet. So this is just an example. Maybe I'm working at an accounting firm and they have types of errors that they want to track. There could be billing errors. I bill the wrong account. Oh, I bill you for the customer for something that I was supposed to bill someone else, or maybe they bill the right people, but for the wrong amount. And same thing, they could receive money for the wrong account or the wrong amount. And just keeping a tally of how often each type happens can visualize which ones happen more often. And then if you order those from most frequent to least frequent, then you get something called a Pareto chart,
Like Rush.
like the Russians.
So you can also like, can you like get like patterns, like maybe say like, let's say like on Mondays, there's more errors or whatever.
Potentially. Trend charts. We'll look at, I think another one of the tools here in a minute could help with some of that. Or if you tracked error by day, then you could sort it by day and say, oh, Monday is the most frequent. This was an example of a Pareto chart I did at a company where we were tracking downtime. They were having a high percentage of downtime, about 35 to 40% on a piece of equipment. They make stranded copper wire, so they would make like this stuff. They had raw material stranded copper, then they'd run it through a long extrusion process and coat it different colors. Some had stripes, multicolored, some different gauges. But they were having a lot of downtime, so they didn't know why. So for a few months, we just had the operators, we worked with a team and the people who run the process came up with about 54 different reasons that their equipment could go down, they could experience downtime. And so then we just had them track on a form, hey, today from this 7:45 to 8:15, we had 30 minutes of downtime and here was the reason, code 52 or whatever. And we would track that and when we consolidate it, and after a couple of months, we started to say, which reasons of those 54 contribute to the most downtime?
So I know, like, I'm working at, I think today's my last day actually, working at GE in the night. And I know notice they keep track of that. They have big boards up and it'll say like every second that the line is down, it tallies it up, it adds it up. So for the night, it'll say, 30 minutes to total downtime. And then it'll say like, if it's stopped before this area or after this area, or like if it's quality, it'll say like PDQ. It'll say, so they keep track of, they have like some kind of real-time metric running thing to do that. I noticed that.
And so what it allows you to do, at least in using this tool, is it allows you to see what happens most frequently. So the Pareto chart is named after an Italian economist named Vilfredo Pareto. Pretty cool name to say. And he had done some studies and basically he had the 80-20 rule, which said in his research, it was 80% of the wealth was owned by 20% of the people. But then a guy we talked about in EM 660, Joseph Juran, when he started becoming one of the top quality gurus, he was inspired by the Pareto philosophy of 80-20 and said, actually, this applies to a lot of things in life, not just economics. So then in the 90s, a lot of businesses went through this fad called 80-20, where they would say, 80% of our revenue comes from 20% of our customers. So let's prioritize them. And then the other 20% of our revenue comes from 80% of our customers. So it's how do we focus on the significant few that contribute to the majority of the output that we're interested in. So if you can look at this, the number one cause of downtime was an issue called a fuzzer. Funny word. Pretty sure I've been called that a few times. So of the amount of time, just a fuzz-up out of 54 causes, just that one cause was about 40% of the total downtime. And if you added the second most common, which was a wire break, if you added those two together, those were about 60 to 65% of the total downtime, just those two causes. And if you throw the third one in, you're right at 80%. So we can have 54 reasons but 3 of them account for 80% of the problems. So the Pareto chart helps you visualize data to drive priority in decision making. Maybe this is where I need to be putting my efforts. Because if I can take care of these two things, I knock out a lot of my issues. But you also have to be careful in how you measure this. Because you could some people will use a Pareto chart to show the same thing, the bigger chunk of the pie, or a pie chart. The bigger chunk of the pie shows you what contributes the most. But you have to be careful. This is a company I work with, and we'll revisit them a little later here in a few minutes. But this is a chart they put together. I was there working on a project with a team, and the CEO called in, and they had been having a lot of shipping errors. And he was like, I'm coming in at 2:00, and I want to talk about this. And that ended my team's efforts because everybody left and spent all morning putting this chart together. And then, so I was there. I'd worked with them a good bit. I liked the company, one of my favorites to work with. So I was like, I want to sit in on this meeting. And the CEO was like, yeah, sure. Go ahead, Nick. You may have some input. I'm like, I promise you I won't, but it'll be entertaining. And they sat there and talked about whose fault the problems were. 45% of our shipping errors were shipping's problem because they're a bunch of idiots. Okay. So it turned into a blame chart, and very rarely is blame a root cause. Usually, if you get to do a root cause analysis and someone's name is on the end of it, you've probably not gotten to the right root cause. These are very specific problems that could be addressed. These are people to blame that really didn't look at the problems that were caused. So still the Pareto chart with the wrong measure. So be careful what you measure. Another thing, and you're going back to if things happen more often on a certain day. If we are interested in two variables and if there's a correlation or relationship amongst them, then a scatter diagram might be useful. Where I can have two axes. And if I want to know, so this is Old Faithful at Yellowstone National Park. And if I had a hypothesis that the frequency of eruptions, the time between eruptions, had a relationship with how long each eruption lasted, then I could start to plot each eruption based on how long it was since the previous one and how long it lasted. And if I start to see trends that look like this, that tells me the longer the waiting time between eruptions, there's a chance that the eruption will actually last longer. And I can visually see that there's a trend there, that there's probably, this is called a positive relationship because when one variable goes up, the other one goes up. So positive relationship is no indicator of if it's a good or bad thing. It's just that when one variable increases, the other one does as well. And it just visually makes that obvious, or it could be a negative relationship, which again, isn't saying it's good or bad. It's just saying as one variable goes up, the other one goes down.
Now you could, can you, I think years ago I did something like it was, you know, where you had like, you measured the fit, never mind, I can't think of the name.
We can come back to it if you think of it. So in this case, it says the more wine I drink, the lower my heart disease chances. I kind of like that.
Good, that's a pretty.
Now, there's a chance that if this goes on out to 10 or 12, it might start to go back up. I don't know. But it just is a way to show a scatter diagram is a proper data visualization tool if that's what we're interested in.
Regression, that's the word.
Okay, yeah. Yeah, you can develop, that's when you have multiple I mean, you could have two variables, but regression can actually be multiple variables and the degree to which they influence an output variable. Also legitimate. A cause and effect diagram, or a fishbone diagram, as I hear it called a lot. If you really want to show off, you can call it an Ishikawa diagram. Was developed by Japanese engineer Kaoru Ishikawa. But basically it's a fishbone diagram because it kind of looks like a fish with bones. The head of the fish will be the problem. And this is effective when it's not very obvious if what the causes could be, or there could be many causes. And then each of the main branches off of the fishbone become the different types of inputs that could go into the process. So in other words, if my problem head of the fish is bad burgers, and that is a problem to me. I like a good burger, and if it's bad, that's a major problem. So it could be, what about the materials in the burger could have made it bad? And I could list the different things. Could be the meat. Maybe it's not fresh. Maybe I used too much. Maybe it was packed poorly. What about the methods, the way it was cooked? What about the machine, the equipment that we use to cook it? What are some possible things that could go wrong with each of those? And then as you start to list them, what happens often is that certain causes start showing up on multiple branches, and that kind of starts repeating itself and hints at somewhere that you can go and look further. And there's lots of other tools. So I guess my point in this phase is to talk about, one, how to properly quantify problems. Two, once you've described the problem, how do you use data visualization to go out, observe the process, collect data to visually highlight the issues so that you can develop countermeasures. Sometimes it's just pictures. This was a constant velocity shaft for an axle manufacturer that supplied Mercedes. And they were having oil leaks. Apparently people who buy Mercedes don't like the car leaking oil. And so that was a problem. We were applying a problem-solving process to it. And this was a spline that would actually be inserted into the differential. And they actually had these oil seals that were being sent back from the customer that had chunks out of them that was causing oil leaks. So we went down, we were watching the process, and this is what the end of the shaft of some of those CV splines look like. And if it may be hard to tell in this picture, but there were sharp edges to almost like if you took a Coke bottle, beer bottle, whatever it is, the twist off tops, and you put it in the palm of your hand, press down really hard. Because we all do that, right? Or am I just crazy? Those jagged edges, that's what the end of that spline. And then we actually lined the oil seal up, and the chunks would line up very much in line with these jagged edges. But then they also had another supplier that would chamfer those down to where it was smooth. And they were not having the problems from that. So we narrowed it down to one supplier. And then we're able to go and look and go, oh, I visually see that that's the difference. And then the picture highlighted that. This is spaghetti diagram. It was just tracking traffic back and forth. This is one person's movement while changing over a piece of equipment. And you can see where they were going. Sometimes they would just walk away and come back. Usually that's because they were missing something and had to go look for it. And that just made it very obvious what was happening. Sometimes data tables, highlighting things. I'm just wanting to point out that at some phase in the problem-solving process, as you're going from general problem description to going and observing the real situation, using different tools to visualize data can help in the root cause, determining the root cause, and help you decide where to focus. And then as you get closer and closer to the root cause, we have another method called the 5 why. Because traditionally, a lot of times, I don't know about y'all, but I've worked at places like this. Sometimes this is still how we address problem solving in academia. If something goes wrong, everybody likes to ask whose fault it is. Who should be written up? Who hired this idiot? Who did this? Who? I didn't do who. And very rarely does asking who actually address the problem. We could get rid of the people without fixing the system, bring someone new in, work in the same bad system, same problems came back. So instead of asking who, we want to develop the mindset of asking why to solve problems. So the 5 why analysis is a method that allows us to systematically ask why to get to a root cause or get closer. Now, there's a very meticulous way that this should be done. The 5 why analysis is not just asking 5 disconnected questions that happen to start with the word why. It's what children do. Why? But why? 5 is a rule of thumb. It may take more than 5, it may take less. But the way to do it is to start with an original problem and turn that into a question that starts with why, and then each successive why question builds off of that previous one based on the answer. So if I have a problem that says we shipped 4 boxes of wrong product, then my first why question, if I'm doing a 5 why analysis, would be why did we ship 4 boxes of wrong product? And then I try to answer. And if the answer was we shipped them wrong because the parts were labeled incorrectly. So the right label on the box, we loaded the box that said it was this. Customer got it and it was the wrong thing. Okay. Then the next question is why were the parts labeled incorrectly? And then you drill down from there. So they're not 5 disconnected questions that happen to start with why. They build off of the answer to the previous question.
I got a
This
question about that.
may seem simple, it's very difficult to execute.
So I've noticed that when I've tried to do that, and you get on people's nerves after a while too. So what do you do to not get on people's nerves?
I communicate, I guess, I don't know. Talk, understand why we're trying to do it, engage them in the problem solving process instead of approaching it as I'm trying to solve your problem for you. Say, this is what we're trying to get to the root cause of. Why do you think that happened? Not why did you do this? Why do you think this happened? Because a lot of times we start off answering these with the wrong answers. And we have to go back and reiterate this over and over again. I'll give you an example here of that. This same chart, the blame chart. And like I said, they spent all morning putting this chart together, and all they said was whose fault were all of these shipping errors that we've been having, and they broke it down by department. 45% of our shipping errors happened because of the shipping department. Another 25% happened because of production, packing them in the wrong box or whatever. Another 15% happened because of customer service. But they didn't talk about why the problem happened. They just talked about who did it. So here was the actual team that we were working with. And I always I told this company this, I've said it to a lot of companies, you can't problem solve from a meeting room. You have to go see what's really happened. You can't assume. You have to go and see what's really happening. And so when they put this up there, 45% of shipping errors happened because of the shipping department. Well, we had done a Kaizen event with a team of people a couple of months earlier where we literally came up with visual standardized work of how to go pick parts from a warehouse and load them onto the truck. Everything from picking the parts to packing it to shipping to loading it on the truck. So I knew we had come up with a standardized method of how to do it that even I could go and follow and probably load the right things to ship. That's how we always test standardized work, is if Nick can do it, anybody can do it. We've made it dummy proof. So I was really curious. So I was like, how did this 5 why actually work? This was a poorly executed 5 why. The problem, 10% increase in shipping errors in the last 3 months. First question, we rephrase the problem as a question. Why were parts shipped to the customer? Because the wrong parts were picked from the warehouse. Why were the wrong parts picked from the warehouse? Because parts were in the wrong inventory location. Why were they in the wrong inventory location? There's a new employee who put them in the wrong spot. Why did the new employee put it in the wrong spot? So the new guy's an idiot. This was the culture of the company at the time of everybody's an idiot. So over half the people are below average. Like that was always like, if everybody's an idiot, like how are we it's impossible for over half the people to be below average. Like that, just numbers don't work out. Everybody can't be an idiot. What's wrong with the system? We can't blame this guy. If we properly go back and instead of saying you guy's an idiot, we say, oh, new employee wasn't trained on the existing visual work instructions that were put in place 2 months earlier. Literally went and talked to him, showed him these. He said, I've never seen them. They just gave me a scan gun, told me to go find stuff, said the gun would show me where to go. In the pig ticket, he wasn't trained on how to actually locate things, double check things, and got tagged an idiot. So if you get to an end of a 5Y and blame is what your root cause was, you probably phrase the answers. So our friend Edwards Deming, who we discussed in EM 660, actually talked about him on Tuesday night in EM 660. Said 94% of the problems are system driven and only 6 might be people driven, focused on improving the system. So usually the root cause exists. We know we've gotten to the root cause when one of these 3 things is the case. There's no standard that exists. So then our countermeasure could be developing. It could exist, but hasn't been communicated, just like we saw in the previous example. Or it exists and it's just not being followed.
Question, is that the anti-Taylor? Is that like a title or is that a book name or?
It's, I think just someone saying Deming's view is anti of that of Frederick Taylor,
Oh,
who the scientific management guy who says, don't think managers will tell you how to do the job. So 5Y should be focused on getting to the root cause. So here's another example. This was a company I worked with that made inflation devices for life vest. And they were having problems with inconsistent measuring causing errors. So they had a problem with 10% scrap from the machine. They called it a pill. It was just a compressed powder, looked like a lifesaver. They had 12% scrap. 5Y worked this way. Why is there so much scrap? Why is there 12% scrap? Because the machine's kicking out good parts. That's how we determined it as scrap to begin with. Why are good parts being kicked out? Because the machine thinks they're defects. So we could literally go to the scrap bin, take a part, run it back through, and it would pass it a high percentage of the time. Well, why does the machine think they're defects? Because the laser measurement system is inconsistent. Well, we were doing a Pareto of the reasons that things had been rejected, and 56% were due to these first 2 reasons, which was either the laser that was doing a measurement was reading too high or too low. So it was measuring the thickness. If it was too thick, it would kick it out. If it was out of spec, because it would take this pill is made, it goes in an inflation device. If you pull the handle, it's supposed to inflate the vest. If you're unconscious and can't pull the handle, that pill dissolves in water and inflates the vest on its own. If it's too thick, it may take too long to dissolve. If it's too thin, it may not create a strong enough pop to inflate it. So there was a design thickness, and if it was too high or too low, it would kick it out. Or the laser measurement was inconsistent. These are 3 measures that we did on the same part. We just ran it back and forth. This was 3 measurements on the same part, and they were wildly inconsistent. Okay, why was the laser measurement inconsistent? The robot arm that carries it wobbles a little bit. And you can see that if you paid close enough attention. And it would measure it as it was traveling, so it could bounce up and down, cause some inconsistent measurement. Why is the arm wobble? There's a worn ball bearing. Now we're getting somewhere. Why is the bearing worn? Because We don't do preventive maintenance. We run it until we start having problems, and then eventually we'll change it. So the root cause, worn ball bearing. So then, once you determine the root cause, then that leads to what countermeasures can I put in place to address that root cause? And usually there's two types of countermeasures. There's a temporary one that we call containment, which is what can we do to immediately stop things? That might be treating the symptom.
Change the ball bearing.
And then, right, change the ball bearing now, but then how do we prevent it from happening long term? Put in a total productive maintenance program with preventive maintenance to where we change it after so many hours of use, whether it needs it or not. Or even do predictive maintenance where I'm doing vibration analysis to detect that it's worn before I can visually detect that it's worn.
Get rid of the ball bearing altogether.
Or come up with a design that doesn't require ball bearing, whatever it is. Those are countermeasures. That's why we don't use the word solution, because there could be a lot of ways to address it. But there's always a short term, which is how do we stop the bleeding right now? Whether it be quarantining something, shutting something down, throwing cardboard under the truck to catch the oil leak, and then the permanent fix. So this was actually the slide. We replaced the bearing, took the slide off, put it back. Was that actual project. So then to verify, and I know this is very meticulous, but developing the right problem solving mentality requires being very meticulous. Is to perform a therefore verification that the countermeasure that we develop actually addresses the original problem. And so the way the therefore verification works is we ask why downward to get to the root cause. Then we develop countermeasures, short-term and long-term. So short-term, replace the bearing, long-term, implement preventive maintenance. And then if I have a good countermeasure, I should be able to make a therefore statement that maps back to each why and addresses it. We replace the bearing and implement preventive maintenance. Therefore, the bearing won't become worn. And see how that maps directly over to there was a worn ball bearing. And if there's not a worn ball bearing, therefore the robot arm won't wobble. And see how that maps directly back over. And if the robot arm won't wobble, therefore the measurement system will be consistent. And therefore the machine will not kick out good parts. And therefore the machine won't read them as good parts as defective, therefore it won't kick it out, therefore we reduce scrap. And if you can map it back, then you probably develop a pretty good countermeasure to address the root cause. And if you haven't, then you probably didn't perform the 5 why correctly, and you go back and reiterate, and it drives you to perform it and execute it more properly. And so then developing countermeasures, we can say if we implement this, what is a target improvement that we could hope for? And so just like setting and quantifying the problem statement with a number, the target should always be measurable and quantified. In other words, how do I know I improved? The target condition should be stated using the same metric or metrics that you used in the problem description. Because that's what you want to improve upon. Very often those are already, if there's an established standard, the target's very often already there. Or if you have a strategic plan, there may be improvement targets that already exist that you're working toward.
So in this case, like you have an already agreed upon tolerance that was allowable as far as the variation.
Yeah, that was a whole other thing. One of the tolerances, what they were at this particular one. But yes, our focus was on, and our target was actually to reduce scrap by 50%. Not just to reduce it in half, but all we were looking at on this project was the laser measurement. And because that contributed to 56% of the scrap, we said if we can take care of this, that'll probably cut it in half. So it wasn't just random, we want to cut it in half. It was, we're dealing with something that accounts for 56%. So that's what we hope our target will be, because that's what we're working.
Did it cut it in this half?
Yeah, cut it more than that. Because interestingly enough, we'll go back and make people dizzy again. But if you notice, two of the other things that it kicked it out for were scale. Yeah. And those, if it was bad and passed the laser measurement, and because it was inconsistent, it might get kicked out because it was too heavy or too light. There's a correlation between the two, but it kind of, because we got it right more the first time, it actually took care of more of those reasons as well. So the target condition should have the same metric or metrics as the problem statement. So here we said the bobbin assembly machine, that's the previous example, had 12% defects over the last 4 months. So now we say by the end of this month, we want it to be less than 6% defects. 56% of the defects is related to the laser. We want that to be less than 0 after this project and reduce the cost greatly. So the point there is when you set a target, always look for set it in the same metrics that you mentioned in the problem statement.
How will it be less than 0? Is it less than 0?
Less than 1. I may have said less than 0, but it says we want it to be less than 1. Been a long semester, man. Give me a break.
I thought I wanted to know, like,
We're all limping to the end. Then when we develop the countermeasures, the do part of Plan, Do, Check, Act is to actually implement them. So some things we try to do there, a lot of times we'll have different alternatives. We could do this, this, or this, and then have a risk matrix to kind of help evaluate those alternatives. Every countermeasure should also have an action plan with people responsible and when it's going to be done. And that just gives you a greater chance of it getting implemented. And just like the check in the Plan, Do, Check, Act cycle is once we go and do, did we actually get better? So we want to measure that. Again, the check based on the same metrics that we used in the problem description and the target condition to see if we got better. Oh, improvement, we got better or we didn't. If we did get better, then the standardize is to come up with new standard work and train people on it. Continue tracking after the fact to see if the problem reoccurs. And if we didn't improve, then we just reevaluate our hypothesis and go back to plan, which is fine. Part of the problem solving mindset is we use the word countermeasures because it's like, oh, we don't necessarily have the best solution, but we have a countermeasure that will address some of the things we see. And if that didn't work, then we'll try something else because the problem's still there, so we shouldn't. So I know I went into a lot of detail, which kind of deviates from the scope of the class, which is strategy. But I just wanted to kind of close the loop on how we go from developing a vision, mission, values that we can't measure, all the way down to strategic goals that at least puts them into categories that we want to succeed in, to objectives with the key results that we can measure at the unit level that get down into tactics and metrics at the process level. And then as we miss those metrics on a day-to-day, week-to-week basis, then we can problem solve to get the process level metrics back to normal, which drives our chances of reaching the operational level plan, which ultimately ties to our strategic goals. So I kind of just wanted to close the loop on all those things in an organization should work together. And then having systems in place to where we use them correctly. So one of our faculty in our department, Dr. Woolley, works on something called digital twin, very trendy thing and in the engineering world these days. But it's just one more example of how do we pull real-time data. It's really cool because you can create a digital twin of an existing piece of equipment or system and then have real-time data on the virtual model that you can monitor using the same parameters that's on the real thing. Formula One does this. Like, as the cars, there's 2,000 sensors in a Formula One car, and like a lot of times the engineers in the pit know what's going on before the driver does. They can detect all these different things. They can see it and they can adjust before it actually adjusts on the car to see what would happen. So that if they do need to make adjustments on the car, they already know what to do before they tinker with the real thing. Really cool. But that's just one way to properly problem solve. The first thing we have to do is have metrics that we've chosen in the planning process that are indicators of real performance, and then having ways to collect and monitor it as close to real time as possible. So we have to have systems to do that. So the strategic planning process should tell us what metrics we need systems to be collecting. Then we have to have good systems to do it. And we have to have people that know how to pull that data and capture. Then, once we have the data, a lot of times we have to verify that it's right, clean it, wrangle it, all those fun data science terms. And then visualize it in some way, like we talked about, that makes it make sense to someone. And then once it's visualized, use that to actually make decisions by either problem solving, planning, and again, it drives decision making, which drives what metrics and data we need to be collecting. So from a big picture, here's what I've seen. Very rarely do skill sets in all three of those buckets exist in the same person. There's people that are really good at coding and getting any data that you could ever want. Love those people because it's not me. But there's a lot of people who's like, I can get it. I run data all the time. I bug the IT people here at the university because I'm always tracking how many graduate students do we have enrolled, by which concentration, PhDs by which concentration, masters by which concentration, years of like that they were admitted and how long they've been at, like I'm running. So I'm pestering them all the time. Please pull this data from me. I don't know where to get it. You know how to get it. Clean it up. Give me only what I need. They're really good at it. I'm not. Then once I get it, I'm doing this.
Dashboard.
I'm visualizing it. And then I'm talking with my department chair and we're trying to make decisions based off of it. How many people do we need in this area, this area, this area? How many people do we have stuck that aren't getting through the system? What new processes do we need to have in place to alleviate some of those issues? I can't make those decisions on my own. I can play this middle role. A lot of times the decision makers need this done for them, and they sure don't know what's going on here. Very rarely today do all three of those skill sets exist in one person. The person who can get the data, the person who can make that data actually mean something, and people who make the decision. In an organization, we need those three things linked together. Because a lot of times I see companies that have a lot of data and don't know what to do with it. They suck, it's there. Sometimes they even visualize it and do nothing with it. Yeah, we suck. Look at the graphs. They're not using it to make decisions. But when we can tie all three together, that's important. And a lot of times they have data that they're pulling and visualizing that aren't the right metrics because they haven't planned strategically enough to know what metrics they even should be paying attention to judge themselves as being successful. So I wanted to close that loop because as we're making this bridge from module 2, which was strategic planning, to module 3, which is strategic leadership, leading problem solving and tying in where it fits into the bigger picture is a critical role in leadership. And deciding how to invest the development of those skills in your people is absolutely critical. Which is, I'm going to just do a little bit of introduction into what we're going to talk about the rest of the module and the rest of the semester. As we make a shift from the problem solving part of leadership to introducing emotional intelligence, is what I'll end today with. So I mentioned earlier tonight, the first decade or so of my career as an engineer, I was going out and doing really cool engineering stuff, improving processes, working with people who do the job, applying problem solving, Kaizen, implementing technical tools that I had learned to eliminate waste and improve processes and get big results. But then what we started to realize is you can improve processes all you want, but if we haven't developed the leadership skills in the people in the organization, does it really sustain? One of the systems archetypes we looked at in module 1 was shifting the burden, and it was addressing the symptomatic solution instead of the fundamental solution. And one of the examples they used was depending on outside sources to fix your problems, and you lose the capability internally to do it, and it just shifts the burden where all of a sudden you're dependent on the outside source. So we always work with people to say, how do we develop these leadership skills internally? And so we started developing leadership training. And if you do a quick search of leadership topics in leadership training, very often these are topics that show up. Conflict management or conflict resolution, some people call it. Teamwork, coaching, how to give and receive feedback. We talked about that with radical candor, right? All good topics in leadership training. And I came across several years ago, I was putting leadership training together, another topic called emotional intelligence. And I was like, that sounds interesting. Emotional intelligence, that sounds contradictory to me. Being an engineer, being from the South where you were told not to have emotions, I was like, what is that? And I started looking into it. And so then I added it. It was one more of these topics that we started integrating into our leadership. Many years later, and much deeper dive into emotional intelligence, I no longer have it as one of these topics. I have it as the umbrella that all of these topics fall. Because there's 4 elements to emotional intelligence, and we're going to go through all 4 of them over the next 3 classes after today. And all of these skills fall under at least one of those 4. And so it went from emotional intelligence is one of the many leadership topics that I feel that leaders need to, it is one of the most critical leadership skills you can have, that if you develop it, improves all of these. So I shared some seminal articles on the topic of emotional intelligence, which just in general is the ability for us to understand our emotions and other people's emotions in real time so that we can also manage them. And in the workplace, manage them to develop better relationships, more trusting relationships so we can improve and work together in problems. So one of the earliest theories on emotional intelligence, and you may see it called, and I'm guilty of calling it both things interchangeably, don't get confused, they mean the same thing. Sometimes you'll see EQ, which is just juxtaposed to IQ, intelligence quotient, or EI, which is emotional intelligence, either way. Dan Goleman, the original EQ theory in the 90s, identified 5 skills of emotional intelligence. his original one of self-awareness, self-regulation, motivation, which is how well do I understand what's driving my actions, empathy for others, and social skills and interacting with others. And then Goldman adjusted, and then another book that I used to require for this course, Emotional Intelligence 2.0. I think I stopped making it required. I still have it as recommended on the syllabus. And so, but I'm using multiple sources on emotional intelligence now. Simplified that into a 4-dimensional framework. And then Goldman's also kind of adopted this over the years. 2 of which fall under developing the personal competence aspect of emotional intelligence, self-awareness and self-management. And then 2 of which develop the social competence of emotional intelligence, which is social awareness and relationship. And so I found emotional intelligence to be greatly beneficial in my life, but I'll keep it primarily to the scope of how it can help us improve in the workforce and be better leaders in this course. But we may take some side roads along the way over the next 3 weeks because I love talking about this stuff. So emotional intelligence 2.0 introduced a framework that was simple, 4 skills. The book even comes with a before and after EQ assessment. I found a different one that I have. One of the participation badges for this module, for this section, is to do emotional intelligence, and simplified version of an emotional intelligence assessment. They have a more intense one. The book, it's paid. It's free if you buy the book. So if you get a used version of it, it does not have very likely that the assessment code has been used. But it allows you to assess yourself in each of these categories. So what is emotional intelligence? It's the ability for us to manage our emotional versus rational brain to make better decisions. And in When You Win, Russ Laraway's book, he actually discusses this a little bit in the makeup of the brain. The way the brain works, and this is where I really get fascinated with psychology, is when you take the scientific makeup of the brain and map it back to our behaviors and decision making. We sense, we perceive, which just means we develop feelings. Those things as engineers we're told don't exist. At the most primal part of the brain, the amygdala, the base of the brain, the spinal cord, it's the most primitive part of the brain. That's where we sense, that's where we feel. We make rational, complex decisions way up here at the prefrontal cortex, the newest but most developed part of the brain, where we do critical thinking. For those senses to reach the prefrontal cortex, it has to travel through something called the limbic system. In the brain, and the limbic system regulates emotions. So emotional intelligence, for me, is our ability to manage from the time we feel and detect I'm having this emotion and this feeling till the time we react or behave or make decisions that are exhibited by our behaviors. The better we can manage that, the more responsible behaviors and decisions, which is what we're trying to do with an emotional intelligence. So it kind of maps back Viktor Frankl, well-known psychiatrist. I can't remember if he's Austrian or German. And on a therapist wall years ago, I used to read this every single time I walked in there. Between stimulus and response, there's a space. In that space is our power to choose response. And in that choice lies our growth and freedom. That space from the time there's stimulus, something something happened and it made me feel something or it made me sense something. Till the time I respond, if I can manage this space, the chance I make a more responsible, logical, rational decision. Not that we don't have emotions, it's actually good to have them. It's the ability to detect them and properly manage them. That's emotional intelligence. And we'll talk about skills and how different leadership skills can improve the different aspects along the way. But understanding, I just wanted to introduce it, and because here's why emotional intelligence is important to leadership in general. And there's three parts that psychologically make up who we are. One of those that we're probably all pretty well familiar with is IQ, intelligence quotient. That fun metric that some kids get chosen and say you're gifted to get this tested, and I was never one of those kids. Intelligent quotient, IQ, is our ability to learn. Our innate ability to detect patterns, critically think, conceptualize things beyond specific, and draw more conceptual conclusions, our ability to analyze data. IQ is relatively stable over a lifetime after a certain age, which is pretty young. So we don't get smarter. We don't get more intelligent.
We're over here.
That doesn't mean, yeah, right. The search for intelligent life ends or continues. It's not here. What does that mean? It doesn't mean we do not learn. Obviously, we learn new stuff every day. Our ability to learn doesn't improve over time. After a certain age, it's relatively stable. That doesn't mean we learn new things. It means we don't get better at innately identifying patterns, conceptualizing, that becomes fixed. Research from Emotional Intelligence 2.0 also shows that after some point, a certain level of IQ, it actually stops being a predictor of effective leadership. It becomes saturated. In other words, the smarter you are doesn't necessarily mean you're a better leader, and at some point it actually means you're worse. But again, very little we can do about it. It's fixed. Another part of who we are is personality. And we'll look at that next week. Personality are references that drive behaviors. So we'll look at this next week in more detail, but there's certain personality traits. And in psychology, personality theory, the most agreed upon is there's 5 personality traits. I remember it by spells ocean. So it's openness, conscientiousness, extroversion, agreeableness, and neuroticism. And each individual has a preference along each of those 5 traits, and a mixture of those 5 traits and your preferences become a personality type. So if you've heard people with the Myers-Briggs say they're an INTP or something like this, and they define their entire life by, that's where that came from. We'll discuss it more next week and its role in actual leadership. But there are sets of preferences, and those preferences, again, are relatively stable over our lifetime. Personality tends not to change. Behaviors will, potentially, but our preferences on those 5 traits tend not to change. And just as an example, like the extroversion scale, it's actually continuum, introvert to extrovert. And there's no better or worse on any of those theoretically traits. I don't know about neuroticism. But there's a continuum. And every time I've taken any type of personality assessment, I'm extremely strong on the introvert side. Like if there was a negative, I would be there. Like it is, and what does that mean? It doesn't actually mean outgoing or not outgoing, as people think. It actually just means, where do you draw your energy? Do you draw it internally, or do you need some kind of external source? In other words, we were talking about this before we started class. I was like, oh, I live kind of in my head. I'm pretty aloof about a lot of things because I forget the outside world exists. I watch very little TV unless it's live sports. I very much would be like, oh, that's fun. I'll go to the concert if somebody makes me, and I would probably actually enjoy it. It is not the last thing that would ever cross my mind to do unless somebody made me, because I don't tend to draw my energy from the outside. But it doesn't mean, I teach for a living. I very much have to be outgoing and be able to engage. It also can be exhausting because I don't draw my energy from the outside and interact. So I have preferences, but then I can exhibit different behaviors based off of those. And we'll look at that more next week. IQ, personality, relatively fixed. The third part of us psychologically is emotional intelligence, and it is the one out of those three that is a set of skills that you can improve. And it actually, in research, is the number one indicator of performance and leadership based on Emotional Intelligence 2.0's research. And it is the fundamental thing that all these other leadership traits can fall within. So that's what we want to dig deeper into for the rest of the semester, is not just emotional intelligence in general, but how do each of these leadership traits fall under emotional intelligence and make us better strategic leaders? Because you can think strategically and not plan, and you've done nothing. Or you can strategically plan without thinking strategically, and you've really only planned. But I can think strategically and have a great strategic plan, but if I can't strategically lead and manage toward that plan, we still haven't executed. So we're going to get good at execution with leadership over the next 3 weeks. Good at execution as in getting things done, not as like Kim Jong-un is good at execution. Supposedly. So that's what we've got ahead of us. I just thought this was Office Space, a classic, just to pull it into perspective. But that's what we're going to be looking at over the next few weeks as we draw the semester to a close. I enjoy that stuff. I know it's really weird to cover emotional intelligence in an engineering class, but that's what makes us different here in our program, because these are things that I've seen. I've been around a lot of leaders at different levels in a lot of different organizations, and I've seen a lot of bad ones and a few good ones. And the few good ones that I've met all were really good at self-awareness, self-regulation, social awareness, ultimately to develop strong relationships to lead their organizations. It's an absolute critical skill, and it'll be fun to talk next few weeks. What do you think? Good. Good, because that's what we're gonna do. No, welcome back. I'm glad to be back in class. I really very rarely miss class, so to do it as much as I have over the last few weeks is something I hope I don't have to do again. This is where I feel safe in my job, is actually in the classroom. It's the few minutes of the week I feel like I'm not working, so definitely was not trying to run from y'all. I'd rather have been here. And I'm glad to be back. I hope y'all have a good week.